All right, so I started talking about this yesterday. It says part 2 because I just want to revisit this again. When you have ordered pairs, so you're talking about parentheses, to find the components of a vector that goes from this one to this one, you take the second one minus the first one, and you write them with these kind of parentheses because you're breaking it into basically the x and y of how you got from one to the other. And those are called the components. And then when you have the components, to find the magnitude, you just do Pythagorean theorem because that's figuring out how long this is. So if I went from, let me make up an example here, -2, -3 to +5, 7, you would say, and it was going that direction, you would say 5 minus -2, 7 minus -3. I would have 7, 10 as the components of this vector, and then the magnitude or length, if it went over 7 and up 10, would be the square root of 7 squared plus 10 squared, or the square root of 149. Okay, that's the magnitude. So we did these all yesterday. We're going to go back and do these in a minute in another way, so I'm going to fly through them real quick. Let's see, 12 up to here was 40, and 41 down to here was -8. Whoops. And then that was the square root of 1664, or 40.8. That's the magnitude. In a minute, we're going to talk about the direction. Okay. -15 to 7 was 22. And when we did that one, we got square root. Well, anyway, it came out, I didn't even write the square root down. I just wrote. It came out 29.1. And on this one, if we just do what it says and go A to B, we'd have 2 to -1 is down 3, 4 to 1 is, or 4 to 3 is down 1, and 3 squared and 1 squared would be square root of 10, or 3.16. All right, that's what we did yesterday, just reviewing, okay? So it's x2 minus x1, y2 minus y1, and then Pythagorean theorem to get the magnitude. All right, but today we're also going to talk about finding direction. So if a vector is in standard form with the terminal point AB, then the component form, if it was in standard form, meaning at the origin. Okay, so standard form of vectors when the initial point is at the origin. I should have read that line first. Okay, then if it ends at AB, it went A to the right and up B, so the components would be the same. The magnitude and direction angle of a vector is given by, well, the magnitude is simply the Pythagorean theorem, but the direction, how do you find this direction in here if you know A and B? Well, if we draw this, we're trying to find an angle. If we know A and B, this angle is opposite over adjacent, so we are going to use inverse tangent y over x to find the angle. All right, so the tangent of theta would be b over a, so we're going to work backwards. So we're supposed to go back to 1 through 3 and find the direction for all of these. Now the direction gets confusing because you have to make sure you're in the right quadrant. The calculator doesn't do inverse tangent correctly all the time based on the numbers you type in. When you go to the right 40 and down 8, you are in quadrant 4, so we need to make sure our angle winds up in quadrant 4. When you go to the right 22 and down 19, you're still in quadrant 4. But when you go to the left 3 and down 1, you're in quadrant 3. Okay, we're going to have some more of these that are a little bit different. So what you do for every time, the formula is inverse tangent of y over x. But the calculator, when you type that, inverse tangent in degrees, -8 over 40. I am not in degrees, but that's okay. Doesn't matter for anything I've done so far. It's going to matter here, though. Second tangent, I already forgot, -8 over 40. Was that right? -11.3. Now let's think about that for a minute. If our vector went to the right 40, that's a long way, and down 8, that's 1/5 as far. So it was 40 to the right and down 8. The angle in here would be pretty darn small, and it would be down into that quadrant. Or you could add 360 to that and say 348.7. Either one of those is fine with me, okay? But it might be one or the other on a quiz if it's multiple choice. Those are the same place. You can just go around this way instead of going -11.3 degrees. All right. This one is in the same quadrant. So when we do inverse tangent of y over x, don't forget the negative so that it knows we're in that quadrant. I already forgot what I wrote. 19 over 22. Got -40.8. Or if we added 360 to that, at 319.2. But those are both in quadrant 4. That's the big deal, okay? Because sometimes we have to do something funky to find the right angle. This is a quadrant 3 angle. So when we do inverse tangent of y over x, anybody know what's going to happen? It's going to think, that's going to knock these out, and it's going to think we're in quadrant 1. Because it thinks we put a positive over a positive. It doesn't know we had 2 negatives. All right, hang on, I got to move this. Inverse tangent, -1 over -3 is 18.4 degrees. It thinks we're in quadrant 1. So what is happening is we went left 3 and down 1, and we're over here. The calculator thinks we're on the opposite end of that. So what do we need to do to 18.4 degrees to make it go all the way around here? Well, instead of going up 18.4 here, we went down 18.4 here, which is past what? We need to do 180 plus 18.4 degrees. You have to figure out what quadrant you're in, and then it's giving you the reference angle. So 180 plus 18.4 is 198.4. These are tricky. Inverse tangent is not tricky. Just making sure it's in the right quadrant can be tricky. All right. This is going backwards for a second. This is given the magnitude and direction. So if I had to draw this, I'd go around 240 and out 18, okay, and label it V, and this was 240. So to find the components, remember from yesterday, you just do 18 cosine of 240, 18 sine of 240, and it should come out a negative because of the quadrant we're in. I'm going to do it on this calculator because it's faster, except I got to go in degrees. Okay. 18 cosine 240, 18 sine of 240. The cosine is just -9, but the sine is -15.588 or 15.6. Okay, or if you did exact, this would be -9 square roots of 3, because the ordered pair at 240 is -1/2, negative square root of 3 over 2 on your unit circle. So the exact value for cosine 240 is -1/2, and the exact value here is negative square root of 3 over 2. This is fine though, unless it asks for exact. All right, so for this one, you just have 5 cosine of 95 and 5 sine of 95. Let's think for a second though what kind of numbers we should be. A 95-degree angle is here. So I'm thinking you're going to have a little negative number and a big positive number. 5 cosine 95 is -0.44. If I do 2 places, you could just do 1, I don't care. 5 sine 95, do whatever it says in delta math, 4.98. Okay, so it went back a little bit, up a lot, because it's 95. It's just past the 90-degree line. All right, moving on. Oh, easy peasy stuff here. When you know the components, so you have already put a vector in component form and another vector in component form, all you have to do to add them is literally add the x's and the y's. How easy is that? To subtract them, you would subtract x minus x's and y's. I'm not going to ask you to subtract them. Scalar multiplication is when you multiply by a quantity like this is 2 times as long as this. Okay, so if this was vector A and I wanted 2 of A, it would become 4, 6. You would just double the components. All right, so real quick, S plus T, you add 4 and -1 is 3. You add 2 and 3 is 5. If it said take 3 times S and add T, you do this one times 3, which would be 12 and 6. And then you're supposed to add the vector T, which was -1, 3. 12 and -1 is 11. 6 and 3 is 9. Okay, this is easy stuff. All right, F minus G would be 4 minus 24 and -2 minus 21. I'm just showing work here, but it's -20, -23. And G plus 3F would be G, which is 24, 21, plus 3Fs, which would be a 12, -6. So if I add those, I get 36, and 21 and -6 is 15. Hope I didn't make any mental math mistakes. All right, there is something called a unit vector. A vector that has a magnitude of 1 is called a unit vector when it's 1 unit long, okay? But any vector can be made into a unit vector by dividing by the magnitude. So if I said we were going to go right 3 and up 4, you could find the magnitude of that vector. By the way, those doubles, guys, are used for magnitude. Length of the vector is 5. Okay, so to make this into a unit vector, you divide both of these by the length. And so it's the same or equivalent to going over 3/5 and up 4/5. We're not going to do unit vectors, but we're going to do something with the combination form of these, okay? Because it's super easy. A unit vector is in the direction of the positive x-axis when it's called I, or go over 1 and up 0. A unit vector in the direction of the positive y-axis uses this j over 0 and up 1. We use what's called linear combinations of these. So if I have a vector that goes 7 to the right and down 2, you can also write it as 7i vectors and -2j vectors. It's just that easy, guys. They use this notation in different applications of vectors. So this one says we had ordered pairs, so we have to first find the components. So 2 went to 5, or 5 minus 2 is 3. And then 2 went to 4, or 4 minus 2 is 2. And then the ij form would just be 3i plus 2j vectors, because they're 1 unit each, so you just put in the I and the j. Okay, that's how easy that is. So we're supposed to do that for these real quick. So -5 minus 2 is -7, and it's going from m to n, it said, right? So -3 minus 8 is -11. There's the components. So in linear combination form, it's called, you have -7i and a -11j. All right. So this one goes up 18 and down 2. So you'd have 18i minus 2j. Take your time and go over that one again if you need to. All right. This is revisiting direction. So if I have this written out, it really means that, remember that I have a -4, 2 as the components. And how do you find direction again? Direction is inverse tangent of y over x. And you have to watch the quadrant. So this one is going left 4 and up 2. So I am in quadrant 2. This is not going to give me the right answer when I do it on the calculator. When you do inverse tangent of y over x, why won't this go smaller like I want it to? All right, inverse tangent of 2 divided by -4 is -26.6. Now, did we go -26.6 degrees to get -4, 2? -4 and up 2 is over here somewhere. Well, it's just in the wrong quadrant, guys. So we need to, I didn't draw that line well or something because it looks like I went too far. There we go. So if we only went down 26 degrees, to get the right one, we need to add 180 to that, so that the reference angle in here is 26.6. So -26.6 plus 180, to put it in the right quadrant over here, is 153.4 degree angle. All right, again, the reference angle to the x-axis is the 26.6 that they went down. We're just going to move it around to this quadrant, so we're going to add 180. And that's anytime you want a quadrant 2 angle, you're going to add to 180 to what the calculator gives you if you're doing degrees. All right, last one is an easy one because it's over 2 and up 17. So it is a quadrant 1 vector. So we have inverse tangent of 17 over 2 gives us 83.3 degrees, which is the right angle because it's in the right quadrant. Okay. Now, if we wanted the magnitude of that vector, you'd have to do Pythagorean theorem. Just trying to recap all the concepts here. And you would get 17.1 is the magnitude. Okay. All right, so adding vectors means we're going to find the resulting force and direction after you add the components. Okay, most applications will require you to add 2 vectors. So here's 3 applications I'm going to go through with you. Monica is throwing a javelin in a track meet. She is running 4 meters per second this way. And she throws the javelin, you could draw it here or here, doesn't matter, at 48 degrees at 28 meters per second, sorry. So there's 2 forces here. The first, she's running straight horizontal. You could use a 0-degree angle. For that vector, okay? It will turn out, if you type that in, you'll just get 4, 0, because the only force is 4 meters per second to the right. And then for the throwing part here, where it leaves her hands, we're going to do 28 cosine of 48 degrees and 28 sine of 48 degrees. I hate when that happens. Make sure you put the angle in with the sine function, not the magnitude. So 28 cosine of 48 and 28 sine of 48. And I typed 40 both times, not 48. All right, so I got 18.74 and 20.81. Now, what is the resultant speed and the resultant direction? Well, the resultant requires that we add these together, and that's literally all you do to find the resultant components. So when you add 4 to this, you get 22.74. Add 0 and 20.81, and you get 20.81. So these are the components. Resultant components. Then you have to use those to find the speed, because speed is magnitude. So we're going to do 22.74 squared plus 20.81 squared and square root that. This is really bothering me that I can't. What do I need to do? Anyway. All right, square root of 22.74 plus 20.81, both squared, gives me 30.8. So that is how many meters per second this javelin is going to be moving at. And it's going to move in a direction calculated by inverse tangent of the y resultant over the x resultant. That's a 7. Put this on here so that you can see what I typed. All right, and we had her going forward and to the right. So this is a quadrant 1 angle, so it's just 42.46 or 42.5 degrees. That is going to be the direction off the positive x-axis for the javelin. All right, so this one, oh, sorry. Walter's kayaking across a river that has a current of 2.5 meters per second, and it shows it moving directly to the right. So we could do 2.5 cosine of 0 and 2.5 sine of 0, because it's just moving to the right. Or it's going to end up to be 2.5 and 0 when you type those in. The kayak, he's trying to kayak straight across the river here, okay? but he wants to end up over here. Oh, what am I doing? Yeah, he's paddling 4 meters perpendicular to the shore. Okay, so he is paddling 4 cosine of 90, 4 sine of 90. So if we type that in, we get 0 and 4. Just to prove it, 4 cosine 90, 4 sine 90. Okay. Then the resultant, remember, means we add them. When we add those, we get 2.54. To find the resultant velocity, we need magnitude. So we're going to do square root of 2.5 squared plus 4 squared. Gives us a magnitude of 4.7 meters per second. After we do that. And what angle will he be making with respect to the shore? Okay. Is going to be the inverse tangent of y over x, where we're plugging that resultant in over here. Inverse tangent of 4 divided by 2.5 is basically 58. It's 57.99. He's going to make a 58-degree angle with the shore. So he wants to end up over here, apparently, but that's not what's asked in this part of the question. There was another question attached to this. If he is currently paddling straight across and the current is pushing him, he will wind up at a 58-degree angle to the shore here. Okay? And he will wind up over here moving at 4.7 meters per second. All right, one more. An airplane is traveling 300 kilometers per hour due east. We can use 300 cosine of 0 and 300 sine of 0, or it will just come out 300, 0. But I'm going to leave it in components because I want to show you that you don't have to do these by all kinds of decimals. A wind is blowing 35 kilometers per hour, 75 degrees south of west. So there's a wind south of west. So off of west, yeah, we don't do these vector problems very often with this directional. South of west means off of west towards the south, it's going 75 degrees, which off of the positive x-axis then would be 180 plus 75, or 255 degrees. So we're going to add the vector 35 miles an hour, add a cosine of 255, and 35 sine of 255. And what we're going to do is we're going to type this plus this, and then we're going to type this plus this, and get our component form. So I'm going to type 300 cosine of, I'm going to clear this all out. 300 cosine of 0, close parenthesis, plus 35 cosine of 255. And then I'm going to do the same thing all over again with sine. So my components say that this plane is going to wind up at 290.9 and negative 33.8. Think about that for a minute. If the plane was trying to go due east, it's mostly still going east 290, but it wound up moving down this way a little bit because remember the wind was pushing it out that way. So it slowed it down to 290.9 and it moved it down in this direction a little bit. All right, so we want to find the resulting speed only of the plane. So we need to do 290.9 squared plus 33.8 squared. $290.9 squared plus 33.8 squared. And then we need to square root that. I didn't put the negative because when you square it, it becomes positive anyway, so I don't bother. All right, 292.85 or 292.9. Miles per hour, kilometers per hour. What was happening here? Kilometers per hour. Now, we used to do a lot of these when it's not COVID days, and I would make you find the angle that it's being blown off course and then discuss how to change that into a directional vector, but it just asked for the speed, so we're going to call it a day. Is there one more? There is. Two forces with magnitudes of 85 and 120 are acting on an object at angles of, okay, so there's an object here, and one is pulling at 35 degrees at 85 pounds of force, and the other one is pulling 120 pounds of force, but it is pulling this direction at 140, again off the positive x-axis, so we're in luck, nothing tricky about this one, which is what I put on the quiz, okay? I didn't put a crazy one on the quiz where you have to do vectors off of south of west or something crazy. All right, so we're going to change these into components. We're going to have 120 cosine of 40, 140, sorry, and 120 cosine sine of 140. And we're going to add that to 85 cosine of 35. Make sure you put the degrees in the angles, not in front. And 85 sine of 35. And we're going to add these two, making sure we close these parentheses, okay? And then we're going to add those two, and we're going to come up with the component vector. So 120 cosine of 140, close parenthesis, plus 85 cosine of 35 is negative 22.3, which makes sense because remember, I should have drawn this at a better scale. This one was pulling a lot harder, right? 120 pounds of force. So it's going to wind up actually moving left. And then if I do 120 sine of 140, close parenthesis, plus 85 sine of 35, I get 125.9 is the y. And that's because, look how they're both pulling. It's going to go flying. If you pulled a rope that way and one that way, it's going to go flying this way, right? It's going to fly up a lot. Okay. Think of it as two forces and you're sitting in here in a little scooter, okay? Or on the ice or something. And these two forces are pulling. You're going to fly in this direction right here. All right. Find the magnitude and direction to the positive x-axis. We're almost done with this lesson. We need to do the magnitude. Okay. 22.3 and 125.9. I got 127.85 or 127.9 pounds of force at an angle of inverse tangent of 125.9 over negative 22.3. Now we're going to have to think about how we find this angle off the positive x-axis, because when there's a negative in here, it doesn't like our answer. But when I type that, I get negative 79.95, basically negative 80 degrees. But this is clearly not pulling at a negative 80 degree angle. It was pulling left and up. This is a quadrant 2 angle. So we need to add 180 to this to move it into quadrant 2, and it's going to be at a 100 degree angle to the positive x-axis. This quadrant, negative, positive, is in quadrant 2. The calculator thought we wanted positive, negative, okay, because it doesn't know the difference where you put the negative here. So it gave you a quadrant 4 answer. So you just add 180. All right. That's it.